Thank you all for joining. Quick intro about me. This is Sri with HCL Technologies. Been in the industry for a couple of decades, doing multiple roles. At present, I get to provide data-driven AI solutions on cloud, especially on Azure for our customers. Before I start, I would like to remind you that I am available for chat during the talk. So as questions come up, please click the chat button to submit your questions. In the next 30 minutes, I want to run through a glimpse of natural language processing, conversational AI, skills we need today for work and research in this technology, some of the state-of-the-art language models, bleeding-edge research, an industry perspective on where NLP is increasingly being used, and then deep dive into healthcare use case. We will be going in depth on services we built that are helping customers today in the medical device industry. Every organization today is somewhere in the trajectory in their respective AI journey. All enterprises are now facing information overload with added complexity of business domain-centric information processing. Conversational AI and NLP is applicable in every industry you can imagine. We are going to explore new techniques to solve multiple new value use cases like summarization in complex domains on medical, contextualization on unstructured data, and conversational question answering system as an advisor in the modern digital data augmented workflows. It is no longer learn and then earn. It is going to be a continuous learning. You will be challenged to learn new things and be comfortable with the uncertainty. First step in this process is to recognize the speed, the magnitude, and the non-linear nature of the disruption ahead in the AI field. In the new post-COVID world, continuous learning is key if you have chosen AI as a career. The industry is going through a broad shift in NLP and conversational AI. I just want to spend a moment in giving you a full view of the data and AI landscape today. Every organization today is a digital organization and every company is a data company. Whatever we do today, data is at the front and center. Multiple events in the history of time in the past decade led to one after another, supercharged the renaissance in the natural language space. As you can see, AI is slowly eating the world and it is going to create more jobs than it replaces. It is going to boost the economic growth. At the heart of this, data is the language which allows business successes and progresses in shifts like Industry 4.0, Internet of Things, AI engineering, and hyperautomation. Just wanted to spend a moment on conversational AI. Conversational AI is the application of machine learning to develop language-based apps that allow humans to interact naturally with devices, machines, and computers using speech. The frictionless customer experience is the main goal of conversational AI. Businesses are thinking beyond the regular chatbots that you are used to today. It needs to be multi-device, multi-channel, multi-modal conversations with highly contextualized and intelligent agents. Mostly the yardsticks is to start with customer experience goals. As you can see in this diagram, from left to right, it is less complex to more complex. It usually starts off as text-based, but eventually what we are moving to is a smart assistant. Majority of the time, you may deal with informational chatbots, which are simply a fake use and question and answers. But what we will be seeing in the course of the next 30 minutes is how it is being used in the transactional and contextual space where there is a sophistication required, where you need to apply NLP, NLU, and NLG. Business models have changed to subscription-based and do not have the burden of ownership anymore. So whatever you are seeing in AI are subscription-based models. Talking about conversational AI, we need to spend the time on the capabilities what NVIDIA, NeMo, the state-of-the-art toolkit, and Jarvis are the good starter pack to get your journey started. And if coupled that with DeepStream, you can also do video recognition of it. What you see here in the diagram is a combination of automatic speech recognition and NLP and text-to-speech, in which we'll be focusing more on the NLP today for the rest of the talk. You use this tech every day. Whenever you use your virtual assistants, you wake up in the morning, when you ask your directions on your commute, when you're communicating with a chatbot, you're already using conversational AI. if you're using Siri, Alexa, Google Home, or even your Geo voice control and talking to your Google Maps, it is all conversational AI today. Conversational AI, one of the pioneers in the conversational AI space is Alexa. They are mainly focused on speech recognition, voice, and video assistant. They provide you a natural conversational interface, queries to conversations, single to multi-user interactions, and they adapt to user pace and style. It also evolves as a system of self-learning, self-aware, and self-serve skills that you might have encountered as Alexa skills. Moving on to the NLP in a nutshell, what you are seeing here is the big picture of what is NLP about. NLP spans across many subtopics in AI, but it is a subfield of AI that gives the machines the ability to read, understand, and derive meaning from human languages. In today's discussion, we are going to cover a particular NLP application we built today in the healthcare space, which kind of touches upon some of the NLP applications in machine translation, the chatbots, or even in voice translation or question answering space. On the right top of the screen where you see a topics based, there are multiple topics that are involved inside the NLP space, and the skills that are required is clearly mentioned here. But I want to point out a few things here. NLP is an ever-growing tech, so whatever you try to learn today probably will fit only for the next 2-3 years, because the shelf life in which this AI models work changes drastically every 2-3 years. We are going to see through it. Just wanted to spend a moment on the NLP survey done in 2020. The reference here is gradient flow. As you can see here, this kind of gives you the idea of where these companies are located, mainly in Asia Pacific. What are the main type of NLP use cases the production system supports? Majority of them are in document classification, or named entity recognition, or sentiment analysis, or entity linking in the knowledge graph. If you really see what are the stages of NLP adoption in the organization, it kind of gives you the sophisticated NLP is still catching up, but a lot of the organizations are in the verge of exploring the NLP. On the left bottom corner there, if you see it, what are the industries where it is really being implemented? You see healthcare is in the top, computer science technology is in the top. And there are other industries slowly, especially financial services, are adopting the NLP a lot. Compared to the 2019, the budget that are allocated to NLP projects in 2020, you can see there is a significant increase of at least 30 to 40%, which kind of gives you the direction in which NLP is growing. Moving on to the specific event by which NLP blossomed in this renaissance in the history of time. Over the past decade, one after another, there is a specific set of papers that came out of either from the Google's or Facebook, where one of the papers that got our attention is Waswan et al. Published a paper just 4 years back named Attention is All You Need. Then born the famous transformer architecture, as you can see in the highlighted portion here. Transformer is the first transduction model relying entirely on self-attention to compute representations of input and output. And to put it in simple terms, it uses the self-attention successfully in a variety of tasks like reading comprehension, abstractive summarization, textual entailment, and in learning task-independent sentence representations, mainly by reading a sequence of words, which is where human is really good at. Moving on to that, today, if you see every news that comes out of NLP, the majority of the NLP models are large-scale models that you hear of. These are some of the state-of-the-art large-scale models that you see today from 2018, 2019 to 20. In 20, it was blossoming to GPT-3, Mina from Google, GPT-3 from OpenAI. And all this comes up with this million or billion parameters, where the number of parameters basically indicates how many different coefficients the algorithm optimizes during the training process. And these huge models are provided by large companies with massive training costs, dominating the hottest area of AI today, which is NLP. The first order effects of this model ripple through applications, making the second order value effects that change the traditional ways of doing business, which you will be seeing in the next slides. We talked about 175 billion parameter model. Now in 2021, we have 1 trillion 1.6 trillion parameter model from Google Brain. It's called T5, text-to-text transformer, XSL, and they have something called switch transformers that efficiently leverages hardware designed for dense matrix multiplications, in turn energy efficient computation on them with tensor processing units. The training cost of GPT-3 that we saw in the earlier slide is in the north of $4.3 million. That kind of gives you the sense of how big these models are, how long it gets to train, particularly in a cloud environment. The trillion parameter model team used something called mesh TensorFlow to train the model, taking advantages of, as you can see in the diagram there on the bottom here, the data parallelism and model parallelism, and in some cases, model and data parallelism together. The similar trend is happening in the computer vision space too, where ImageNet classification is being decreasing by a factor of 2 every 16 months. That kind of gives you the size and scale in which the change is happening. I just want to spend a minute on a cutting edge technology from Facebook AI research recently released in June of 2021. The North Star of many AI research programs has been continuously learning to better recognize and understand speech simply through listening and interacting with others, similar to how the babies learn their first language. This requires not only just analyzing the words that someone speaks, but also many other cues from how these words are delivered. The speaker identity, emotion, the hesitation, and interruptions all are being captured, and NLP techniques are applied on that, especially from a speech synthesis standpoint. AI system must distinguish and interpret noises that overlap the speech signal. For example, if you are laughing or coughing or lip smacking, or if there's a background noise or a bird chirping, AI should be in a position to understand and distinguish it and interpret that. To open the door for modeling of this type of rich lexical and non-lexical information in audio, Facebook released something called Hubert, a new approach of learning for self-supervised speech recognition and representations. This will enrich existing AI applications, especially in the NLP, with full expressivity of spontaneous oral language, so that an AI voice assistant might speak with the nuances and the effects of a real person. Giga speech is another area of interest that you may have, an evolving multi-domain corpus, especially in the automatic speech recognition, that might be of interest for researchers. The deep learning has its root, especially from the knowledge graph is applied in NLP2. This is just a representation of some of the papers that got released, especially from the point of view of graph neural networks for NLP. It is one of the dominant approach, especially from a deep learning standpoint in coping with various tasks. This table kind of summarizes the deep learning on graphs, especially from the application of it and the tasks that are used to perform and the evaluation metrics. Some of the metrics like BLEU, which stands for bidirectional lingual understudy, and as well as ROACE. Some of them are used for summarization tasks for scoring. And there are many other scores you can see here, depending on which kind of application and task you are going to use it. I just want to spend a minute on the industry perspective things here. I just picked up a couple of industries here. From a cross-industry perspective, you can see that neural machine translation, chatbots, market intelligence, sales and advertising mainly uses it in terms of understanding the target prospects, strike a conversation, or schedule appointments, and much more. 80% of customer interactions today are using chatbots, and by 2024, it will be almost 100% as per the predictions. With user-relevant data and improved models each year, the bots are going to provide fully personalized experiences, devoid of the stress of human-to-human communication. The famous example today that I can quote is, you are not searching Google, think again. If you are searching Google, it is actually searching you with your preferences, which is basically an AI incarnation of your super amplified version of yourself. Some of the healthcare services and financial services, as you can see, mainly in the clinical evaluation reporting, whether it is a virtual scribe or you want to do a clinical trial matching, or even if it is a decision support, healthcare is seeing a surge in the NLP applications, especially from financial services, whether it is a banking experience or classifying financial documents or doing data research or even having a customer engagement experience. NLP is everywhere there. I just want to spend a minute on showing you what are the topics to choose in natural language processing, especially in 2021. These are references from International Conference for Computational Linguistics and Natural Language Processing, ICNLP, and some from the requirements engineering. Every topic here is an opportunity for academic institutions to build courses around NLP for learning, training, and research. This is just a glimpse. It tells you what industry pioneers are expecting from academic institutions and future technology, especially in the top conference. This gives you the broad idea and how broad this is and how wide this is across every industry and how deep it can get to provide business value eventually. This is kind of give you a reference of every year there is a 45 to 50% growth in the number of papers being submitted, especially from an NLP standpoint, and it also kind of gives you the organizations, the prestigious AI research conferences and the organizations that are out there at the forefront. It goes without saying, we need to understand the AI world, where it is heading, and these places are the place to look out for. And the word cloud here kind of gives you the topics where our young dynamic student demographic today needs to be trained, under which the research papers are submitted. As you can see from this diagram, the supply and demand concentration of AI talent flows in the direction in which this image is showing you. As a result, the technology breakthroughs and capabilities are inherent in that direction. DeepMind's AlphaFold, the protein folding model, is a cornerstone in scientific community, especially from an AI standpoint. It is going to go beyond AlphaFold to structural biology, drug discovery in 2021, and it's apparent in the COVID and post-recovery. As Jensen put it earlier in one of the discussions, for the very first time, the computer could automate the process of automation itself, and that is happening mainly through NLP. I just want to switch gears here and kind of explain a particular use case that I promised you earlier, which is in the healthcare space. What you're seeing here is a bird's eye view of a big picture of what we built recently for something called medical device regulation, which is a multi-step process, federally mandated exercise, where the customer has to, especially the doctors and medical writers in medical device industry, has to go through a lot of published medical journals to understand what their device specificity and what the researchers are talking about it. Are there any particular benefits? Are there any limitations on that? For that, we built a system here on the right, what you see here. It kind of gives you the glimpse of taking structured, semi-structured, and unstructured data, whether it is in a PDF or in XLS or doc, processed through the Azure cloud using all the cognitive services available, which kind of gives you a human-like parity to read a paragraph in a document. It uses something called machine reading comprehension to grab the concept part and try to answer the question in a human-like way. It uses a neural network architecture where it understands the subject, the concept, the conditions, the predicate, and when and who part, and attention-based gated model to bring the innovation in chatbots for you. Well, in the next 10 minutes, we are going to do a quick walkthrough of a few things. We are going to understand this problem and encode that problem into NLP and NLU as a business problem set, and then codify the process of applying AI just to give a glimpse of it. And then we will do algorithmic walkthrough and apply this NLP NLU to decode the business requirement to a series of AI models. Okay. The problem statement here is every year there's hundreds and thousands of papers that get released, and in the last 4 or 5 years itself, as you can see it here, the number of papers that comes with deep learning and machine learning in the medical field is increasing by a factor of 50%. So that is why we call medical and health is going completely through an AI shift, which is a new era in medical. It might not be easy to predict the future, but it is safe bet to say that medical doctors and medical writers will not be replaced by AI, but those who are using AI will be preferred and more popular than the one who do not use AI in the next few years. I also recommend How Artificial Intelligence Can Make Healthcare Human Again by Eric Topol, a cardiologist. It's a must-read book for this. In a nutshell, we start with one goal. We want to reduce the burden on the team of doctors and medical writers to go through all these published medical journals to figure out the aspect of understanding the conceptual nature of what the document is and summarize it like a human task, rather we understand the task and see how an intelligent solution, AI models can help to compress the end-to-end time frame here for all the activities shown here. You may not need to know all the activities that are shown in the boxes here, but every CAD task here can be applied to an AI model and get the same human parity in terms of efficiency. Sorry. We will see how all these different pieces fit together and emerge as a use case. I want to spend a minute on the architecture preview. Our AI labs do a pioneering work that brings together NVIDIA's deep AI experience, the powerful supercomputing capabilities of NVIDIA DGX, which is a powerful supercomputer to do deep learning. Our collaboration with NVIDIA enabled the clients to quickly deliver on the full promise of AI solutions to transform their business. The power of DGX in what we deliver as proof of concepts and prototypes with fast turnaround times to customer is the main key to our success. Let me also paint a different kind of picture for a moment, right, if I may. When the AI changes are unprecedented, as the technologies develop so fast, every 6 months there is some new model is coming, which is super fast. We do not have the capacity to drive new things if not the supercomputing hardware available from NVIDIA and the corresponding SDKs that are available from NVIDIA to make that happen for us, thanks to NVIDIA. Just stepping on to this use case that we discussed earlier, we take a bunch of published medical journals which are hard to read other than the human doctors and human medical writers. For a normal person to read that and understand it takes time. Today, a team of doctors and a team of writers spend at least 4 to 5 weeks to go through a bunch of documents, especially the published medical journals, to understand and summarize them, understand the benefits, understand the limitations, understand some of the events that are being mentioned in the document, and put it in a document to submit it for the MDR process. Can we apply AI there? And that's where these 4 steps come into play. Classify, recognize, validate, author are the key titles for those, but we will deep dive into some of the aspects of what classify does. Classify is basically a categorization and discovery and de-identify process. Once we ingest the data, which is in a PDF document or XLS document or any other document which is in unstructured form, we take it and run through a set of modules, data processing units, and then apply some AI models on top of it to produce these mentions. Who are all being mentioned in the document? What are the benefits being mentioned? What are the complications that we need to list out? What are all the age group they are referring to? Is there a sentence classification, especially from a text analytics for health we can do using Azure? Is there adverse event being mentioned? Is there a knowledge base we can create from the published medical journal so that it is available when the next time when it comes? So what you are going to see next is basically we are going to use big models called BioBird and Clinical Bird. These are all names that you don't need to understand now, but these are all big models that are out there based on the bidirectional encoding representational transfer, which is for BERT, short form BERT, is being used to identify whether it is a mention or a particular sentence or a limitations. So this is just to give you a snapshot of what a text analytics for healthcare with Azure will be. The text on the top is just a basic text, but as you can see it, the AI is able to identify the diagnosis, the examination name, the relational operator, is it an abbreviation for a particular UMLS reference here, especially from the medical terminology and the treatment name associated with it. All can be done without any human intervention today. Just to give you an additional screenshot here, the healthcare report. This is one of the healthcare report in the US that you see here, where a doctor has physically examined with particular vital signs, neck, lungs, in the text that you see on the top. The AI is able to understand the administrative event, the age, the body structure, the examination, the measurement units, values, the medication name, and the value of examination, whether there is a symptom or sign, especially in the COVID. Think it of this way. This is no longer require a human to work through all of this, or you need a specialized medical writer or a doctor to understand all this. This is a specific word cloud that we built. This is not a normal word cloud. It is an AI-based word cloud that is built using Keybird. And this kind of understands as and when there is a new document comes, if there is a common pattern of particular medical terms that are being really used again and again, just to identify and easify the process for you. The what if the AI can identify the key topics for you without you have to sift through the documents. That is what it is trying to showcase to you. Just to apply on the same lines of classify, what if AI can run through all the document which are 8 to 18 pages or 20 pages long and understands what are all the benefits in the document. What you are seeing is some of the highlights of the benefits that it identified through AI, and we put a score in front of it just to give you the comfort how accurate it can be for the human to judge on it. And the next you see is limitations here. Again, it goes through a particular set of screening process and the AI model applied to understand limitations. And this particular one, we use the Chan-Zuckerberg model from Facebook. It is able to understand 78,000 method mentions across 36K biomedical research data set it already went through to build that model. It can even understand what method we are referring to, especially from RNA sequencing and bioinformatics. And the data point, for example, here you see a CHIP sequence. It is able to understand that is a method versus GSE 66302 is a data point for you. This approach was based, as I told you earlier, on the pre-trained model. This is one of the recent things we are working on here. One of the customer asked us to really understand, given the document, can you tell us what are the complications that you can and identify the symptoms associated with that complication without a human intervention? So determining that significant complication from the literature is still a work in progress, but as you can see, just in the first one or two models that we apply, we are able to understand or even do better than human in identifying that. The second step of the process is to do a recognition. That recognition has many levels here. The tagger is one of them, entity linking is one of them, transforming that identified entity and then recognizing the entity through BioNE or named entity recognition or ScienceBird. The organizations that kind of gives you the UMLS, the Unified Medical Language System, medical subject headings, gives you a glossary, a dictionary for you, especially from a biomedical entities, for extracting biomedical knowledge. We use them and build the model around it to identify the subsequent steps. What you see here is the out-of-the-box NER that we provide by applying some of the SPACY models and ScienceBird models. It easily identifies whether there is a risk or an injury, or is there a specific clinical trial they are referring to, or the protocol they are referring to. Just zoom out a bit and understand if this can be applied in a complex domain like medical. Imagine what can be applied for other domains. This is another tab just to showcase you how a biocreative chemical disease relation, BC5CDR, can be identified. The chemical and the disease relations can be identified in a given document. And there is another model called HUNER, which kind of identifies several entity types like cell line, chemical, gene, protein, species, which one you are referring to. The third step in our process is to summarize. Summarization requires a human comprehension today, but in our case, we can do it with both extractive and abstractive methods. And abstractive is like human-like parity. What you see here is extractive. It uses an AI model to do a regular way of doing it. And abstractive model kind of gives you the predicted summary as close to the ground truth summary, which is nothing but a human parity of equivalent to it. It is almost the same as you can see it. And just moving on to the next step is knowledge mining. We kind of also use some of the machine translation. As I mentioned earlier, some of the models we use are M2M100 and MT5 to do multilingual tasks. We also use human in the loop. We always recommend human being in the loop because models can do only certain things. But the key takeaway is wherever there is human need to be involved, human need to be helping and augmenting the process of AI. If you understand the intelligent clinical evaluation, I just want to quickly spend on contextualization. Contextualization is in every industry today, in auto, insurance, aero, financial, wherever you go. It's all these documents are contextualized to that particular domain. Is there anything we can do in contextualization with NLP? Yes, we can, especially from dialogue agents like a chatbot that you use with question and answers. We can decontextualize. Given this sentence, will we be able to understand what they are actually referring to the given decontextualization? as well as contextualization, where the information is spread across XML, PDF, docx, let's say in an industrial place, and then there are design artifacts and service manual. Can you combine all of them and make sense in one format so that there is a chatbot that can actually answer you on the predictions of it, which is what this is about. These are the set of references. I just wanted to give it to you as a reference. And I want to conclude with 4 particular areas of interest for academics. I would highly suggest that academics should consider scaled development of key AI products, significant enhancement in AI overall core fundamental capabilities, deepened development of intelligent manufacturing, and establishment of trained talent pool for an AI industry support system. Thank you.